Welcome to TechPacks. Today, we're diving into an exciting new project, the IoT-based load monitoring and control system using mobile app. This system leverages the power of an ESP32 microcontroller to monitor and control electrical loads across 3 different rooms using a custom-built mobile app. With this system, you can set load thresholds, monitor device status, and even turn devices on or off, all from the convenience of your smartphone. Now, let's see the IoT-based load monitoring and control system using mobile app in action. First, we power on the circuit. You'll notice the initial message displayed on the 20x4 LCD screen, which shows the system's name. The LCD then updates to show the current status of each room, indicating whether devices are on or off and displaying the current load value. Next, we'll connect our mobile application to the system through IoT using the MQTT protocol. This connection allows us to control the system remotely. We start by setting the current threshold using the mobile app. Initially, we'll set a moderate threshold to allow some testing. Now, we'll begin turning on devices from device 1 to device 9, one by one. As each device is activated, you'll see the corresponding output on the system and updated status on the LCD. After that, we'll turn off devices randomly to demonstrate the control capabilities. Finally, we'll purposely decrease the threshold on the app to see how the system reacts. As expected, once the current load exceeds the set threshold, it shows alert on both hardware and mobile app. If the load is not decreased within 10 seconds, all devices will be turned off automatically. Let's observe what happens when we decrease the current load by manually turning off a device during an alert. We have set the current threshold to 700. We'll start by turning on the devices one by one until the alert is triggered. Now, I will turn on the second device. As it powers on, you can see that the current load of the system is below the threshold at 643. However, as soon as I turn on the third device, the system may exceed the threshold, potentially triggering an alert on both the LCD and the mobile app. Now I will turn off a device to reduce the current load. You can see that the system returns to normal operation. This safety feature prevents overloading and ensures efficient power management. Now, we will turn off the rest of my devices one by one. That's all about the demonstration part. Now let's move to next part of our video. Thank you. Let's briefly go over the components used in this project. ESP32 microcontroller. The brain of our system, handling all the data processing and communication. Relays. These relays are divided among 3 rooms, controlling different electrical loads such as sockets and bulbs. 20x4 I2C LCD displays the current status of each room and the total load, providing real-time updates. Current sensor measures the current load to ensure it stays within safe limits. 5 volts 20 SMPS, switched mode power supply, powers the relays and other components, ensuring stable and sufficient power delivery for the entire system. Now let's take a closer look at the circuit connections for our IoT-based load monitoring and control system using mobile app. ESP32 microcontroller. The ESP32 is the core of the system. It manages the communication with the relays, current sensor, and the 20x4 I2C LCD. The ESP32 is connected to the 8-channel relay module through its GPIO pins. Each GPIO pin is assigned to control one of the relays, which in turn controls the electrical devices, bulbs, and sockets. The relays act as switches for the electrical devices. The common COM terminal of each relay is connected to the live wire from the power supply, while the normally open NO terminal is connected to the respective bulb or socket. This allows the relay to control whether the device receives power or not. Current sensor. The current sensor is placed in series with the load, meaning it measures the current passing through the devices connected to the relays. The sensor outputs an analog signal proportional to the current, which is fed to the ESP32 for monitoring and threshold checking. 20x4 I2C LCD. This LCD screen is connected to the ESP32 using the I2C interface, utilizing the SDA and SCL lines. It displays real-time information about the status of the devices, on or off, and the current load in each room. This gives a visual indication of the system's performance and helps in monitoring. Power supply, 5-volt 20A SMPS. The SMPS is used to provide the necessary power for the relays and other components. It ensures a stable 5-volt DC output capable of supplying up to 20 amps, which is sufficient for driving the entire circuit, including all 8 relays. Electrical devices, bulbs and sockets. The relays are connected to bulbs and sockets in the circuit. The bulbs used are of different wattages, which allows us to simulate different load conditions. The sockets can be used to power additional devices as needed. This setup allows you to monitor and control multiple electrical devices in real time, providing a robust solution for load management and control using IoT technology. Now, let's talk about programming the microcontroller. In the setup function, we initialize the ESP32 by connecting it to Wi-Fi, setting up MQTT, and configuring the LCD display with a welcome message. We also set all relay pins to off and calibrate the current sensor. The loop function continuously monitors the current load. If the threshold is breached, a warning is triggered, and if the load stays high for more than 10 seconds, all relays are turned off for protection. The system status is then updated on the LCD and sent to the mobile app. The MQTT callback function handles incoming MQTT messages. The setup Wi-Fi function connects the ESP32 to the specified Wi-Fi network. The reconnect function ensures that the ESP32 maintains its MQTT connection. If the connection is lost, it attempts to reconnect every 5 seconds. The parse packet function processes incoming MQTT messages to extract relay statuses and the current threshold. The get current load function measures the current load using the sensor. The start warning function activates a warning if the current load exceeds the threshold. The flash warning function flashes an alert message on the LCD every half second while the warning is active. The stop warning function stops the warning and clears the alert message from the LCD when the load returns to normal. The turn off all relays function turns off all relays and updates the LCD to show that all devices are turned off due to an overload. The send status to app function sends the current load and relay status to the mobile app via MQTT. Finally, the update LCD function updates the LCD display with the status of the relays and the current load, provided no warning is active. That's all about programming part. And that's a wrap on our IoT-based load monitoring and control system using mobile app. This project showcases how you can effectively monitor and control electrical loads in multiple rooms using just a mobile app. With features like load threshold setting, real-time device status updates, and safety mechanisms to prevent overloading, this system is a powerful tool for efficient energy management. Visit our website to buy the complete package. Simply browse our website techpacks.ca, select the item or project, click on the Buy button, fill in the required information, then securely proceed to checkout, and you're ready to begin your project journey. Explore our website now to get started. Don't forget to like, share, and subscribe to TechPacks for more innovative tech projects. Thanks for watching, and we'll see you in the next video.